Hello, pre-algebra students, and welcome to Chapter 9.6, which is all about special right triangles. Earlier in our lessons, we learned how to find the side lengths of right triangles using the Pythagorean theorem, and now we're going to use special right triangles to solve problems. Let's get started. Let's take a look at this picture to begin understanding our special right triangles. A diagonal of a square divides it into two equal triangles with 45 degree, and 90 degree angles. We call that a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the legs are going to be the same length. You can see that indicated here in this triangle by A, and A representing our legs. And if A represents the length of each leg, then we can let C, here, represent the length of our hypotenuse. So we can use the Pythagorean theorem to relate A and C. So C squared, the length of the hypotenuse, will be equal to A squared plus A squared. If we simplify that statement, it's C squared equals 2A squared. That could be further simplified by finding the square root and solving for C by taking C equals the square root of 2A squared. That can be simplified even further to say that C equals A times the square root of 2. Since it's A squared, we can pull that A out and leave the 2 under the radical. So this is our derived formula for finding the hypotenuse length of a special triangle. In words, that formula tells us that in a 45, 45, 90 degree triangle, the length of the hypotenuse is the product of the length of a leg and the square root of 2. To write that algebraically, we would simply say hypotenuse equals leg times the square root of 2, or hypotenuse equals A times the square root of 2. Let's use that formula to solve a problem. The picture shown is a mat used for floor exercises at a gymnastics competition. It's a square with side lengths of 12 meters. Imagine that a gymnast starts in one corner and does a tumbling routine along the diagonal to the other corner. To the nearest meter, how long is the gymnast's path? Well, let's use our formula that hypotenuse equals the leg times the square root of 2 to solve for that length. So this is a 45, 45, 90 triangle, so we can use this formula. So the leg times the square root of 2 is going to give us 12 times the square root of 2. So if we calculate the square root of 2 on our calculator and multiply by 12, we're going to get approximately 17 meters. So the gymnast's path across the mat was approximately 17 meters. And here's our second special triangle. This is a 30 degree, 60 degree, 90 degree triangle. So you can divide an equilateral triangle. Remember, an equilateral triangle has 3 sides of the same length. You can divide that triangle into halves, as shown, that make two 30, 60, 90 degree triangles. So in this diagram, the equilateral triangle has a side length of 2A. See that here? Each right triangle has a hypotenuse, that's the length 2A, and a shorter leg, that's length A. So let's let B be the length of the longer leg. So by the Pythagorean theorem, we can do this. We can say that 2A squared, that's the length of our hypotenuse, right, equals A squared plus B squared. Those are the lengths of our legs. So by rearranging this, we could then say that B squared equals 4A squared, because that's what 2A squared would be, right? 4A squared minus A squared. That's going to simplify to B squared equals 3A squared. Now we solve for b by finding the square root of each side, which is going to give us b equals the square root of 3a squared. We can simplify that one more step and get b equals a times the square root of 3. So now we've just derived another formula for finding the leg or hypotenuse length for a 30, 60, 90 triangle. Let's describe this in words. In a 30, 60, 90 degree triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is the product of the length of the shorter leg and the square root of 3. We know that because we just derived that formula using the Pythagorean theorem, right? So if we were to express this in an algebraic equation, we would say that the hypotenuse equals 2 times the shorter leg, which would equal 2a. And then the longer leg is going to equal the length of the shorter leg times the square root of 3, or we could write that as a times the square root of 3. Let's apply this to a problem. So here's our triangle we'll be working with. This is a 30, 60, 90 degree triangle. We know that the length of the shorter leg is 8, the length of the longer leg is y, and the hypotenuse is length x. So our first job is to find the length of the hypotenuse. So we're going to begin by recalling that hypotenuse is equal to 2 times the shorter leg. In this case, the shorter leg is 8. So our hypotenuse is going to be equal to 16. So x equals 16. Now, to find the longer leg, so in this case y, we're going to take the length of the shorter leg, 8, times the square root of 3. So we can't simplify that any further. So we'll simply say that y is equal to 8 times the square root of 3. Ta-da! We solved it. And here's your first and only checkpoint for this section. Find all of the unknown lengths for each of these problems, 1, 2, and 3. So find both the length of x and y for all 3 problems. Remember, you're going to use that 30, 60, 90 triangle formula or that 45, 45, 90 triangle formula to solve these problems. Press pause while you work. We have one fun real-world problem with a special triangle after this. This really cool building is at the Massachusetts Institute of Technology. It's called Building 66. It's an engineering laboratory, and it's approximately a 30 by 60 by 90 degree triangle at its base. Cool, huh? So the length of the hypotenuse of the triangle for this building is about 294 feet. You can see that in the diagram drawn right here. So we're going to try to find to the nearest foot the lengths of the legs of the triangle or the other sides of the building. Okay, so we're going to use that formula that we know for the 30, 60, 90 degree triangle, the 2 formulas we know. So first we're going to find length x, which is the shorter leg. All right, if we know the hypotenuse is 294, then we know that the hypotenuse equals 2 times the shorter leg, or 2x, right? So x must equal 294 divided by 2, which is going to be 147 feet. So let's go ahead and put that in. 147 feet. Okay. Now we can solve for y, the longer leg. So we know the longer leg, I'm going to label that LL for long leg, equals the shorter leg times the square root of 3. So our longer leg is y. Our shorter leg is 147 feet times the square root of 3. All right, so I'm going to use my calculator to estimate or to calculate as close as I can here. And the square root of 3 times 147 is going to give me about 255. So y is equal to 255 feet. So the length of the shorter leg of this triangle, or the shorter side of the building, is 147 feet. And the longer leg is about 255 feet. Maybe someday we can all visit this cool building together and see this special right triangle in action in architecture. Enjoy these exercises, and I hope you've liked learning about these special triangles. See you tomorrow.